So NAD is one of those things about longevity. Inside every cell of your body, you have chromosomes. You got one from mom, one from dad. You put those together, you get you. On the bottom of your chromosomes, on the little flanges that live out, are these things called telomeres. Telomeres determine how long you're going to live. Doctors can do an electron microscope of telomeres. If somebody has long telomeres, they're going to live a long time. Somebody has short telomeres, they're not going to live very long. That's why you got 6 weeks, you got 6 years, you got 60 years. Whatever it is, if you have long telomeres, you're going to live a long time. Unless a piano hits your head, unless there's an accident that happens and does that. But basically, the longevity of the human body is determined by how long the telomeres are. And so one of the things, what do you think are the things that diminish your telomeres? What if you smoke? What if you drink? What if you have high stress? What if you don't sleep well? All of those things that we call activities of daily living are the things that diminish the telomeres over time. So when the telomere hits the chromatid, the chromosome, you die. Okay. NAD has been shown to stop the degeneration of the telomeres and actually regrow them. This stuff is literally the fountain of youth. You can add healthy years to your life by regrowing your telomeres. It's all about mitochondria, and I told you I get a little bit of technical. Mitochondria are what make energy. So we eat food, we convert food into glucose or fats, and we put glucose and fat inside the mitochondria. And inside the mitochondria is this process called the Krebs cycle that spins this fat or sugar around and produces a substance called ATP, adenosine triphosphate. That is an energy packet. Everything in your body requires ATP. For you to blink your eyes requires ATP. For your heart to beat requires ATP. For you to breathe requires ATP. All of the functions of the body require ATP. So we eat food, we convert it into glucose, we put it in the mitochondria, we store ATP. So one of the things that NAD does is it helps facilitate that Krebs cycle. It powers up the mitochondria so that you can make more ATP. If you have more ATP, it means you have more energy. You can go fix stuff. If there's a cell that's breaking down, you've got all of this excess, this margin, you can go fix it before it ever goes back. If you don't have a lot of energy, if you don't have a lot of margin, you're letting your cells get older and older and older. And the older a cell gets, the less it works, just like in human nature. The older we get, the less we want to take the stairs. We're going to take the escalator. We're going to park by the door instead of walking in. So that's the same way our cell does. And people don't realize this, is that every single cell in your body has a short lifespan. Red blood cells literally last 90 to 120 days, and then you make all new ones. People have broken bones. Bones grow back together. People have lost blood. Their blood comes back into them. You have to get haircuts. You have to trim your fingernails. All of your body's in a constant state of breaking down and rebuilding. So when we give the body what it needs to build healthy cells, and we have margin and we have ATP that can do that, our cells never get old enough to become diseased. That's why NAD is such an important thing. This is an amazing process. It is literally the fountain of youth.